This is video number 3 on transformations, specifically rotations. In the last 2 videos, in video 1, we learned about translations and reflections. And then that was in the first video. In the second video, we learned about dilations. And for our last video, we are learning about rotations. So translations, a good way to remember that is thinking about objects sliding. For reflections, think about flips. For dilations, think about it getting bigger or smaller. And for rotations, we are going to be turning these images. All right, thank you for the interpreter for helping us with this lesson. We really appreciate it. Next slide. All right, rotations, we said, are turns. A rotated figure is a figure that has been turned about a fixed point. This is called the center of rotation. Usually we'll have you rotate an image around the origin or a specific point. Right? A figure can be rotated up to 380 degrees or more. Rotated figures are congruent to their pre-image figures. Your dilations are similar. Right? They're similar to their pre-image, but reflections, translations, and rotations are congruent. Objects can be rotated at different angles. The most known are 45 degrees, 90 degrees, 180, 270, and 360. And those are the ones we are going to be looking at today. Next slide. So let's review the angles. All right, these class notes should be pretty simple when you're taking notes because you're just drawing the axes just like this pretty much over and over again when you're doing these. It's pretty simple. You do not need graph paper and you do not need to make a grid. It's pretty easy to do. Okay, so just draw the 2 axes when you are doing these examples in your notes. All right, let's get started for the rotations. Let's talk about the angles. An angle looks like this, something like this, where there is a distance between these 2 rays. All right, a ray has an endpoint and an arrow on one side, showing that it's going on forever. But when you connect 2 of them, there's a space in between, and that's the measurement of an angle. When there is no space in between, that is 0 degrees. So for right now, we can picture this as being 0 degrees, right here, 0 degrees. Okay, let me redraw that because that looks kind of funny. All right, so this is 0 degrees. Think of it that way. Now, what kind of angle will this represent right here? Hopefully you are thinking 90 degrees. That is right, because from here to here, from here, and this one right here, this ray, put them together, they share the common vertex right here. That's 90 degrees. Well, if that's 90, what is halfway? How much is that? What's half of 90? 45 degrees. Well, what if I go all the way to here? How many degrees is that? 180 degrees. Makes sense. A straight line represents 180 degrees. A straight line represents 180 degrees. Very true. What if I go all the way to here? Okay. That represents 270 degrees. And if you go all the way around, that's 360 degrees. From here to here, that's 90. From here to here is 90. From here to here is 90. From here to here is 90. 90 plus 90 plus 90 plus 90 makes your 360. They're quadrants. Here's quadrant 1. Here's quadrant 1. Here's quadrant 2. Quadrant 3. Quadrant 4. Right? Quadrant. Divide by 4, you get 90 degrees. All right, so hopefully this helps you out. Well, this will definitely help you out. You need to know this in order to do the rotations correctly. So you might just want to review this, draw this again, draw the 2 axes on your paper again, and show me how much is it from here to here, from here to here, from here to here, and from here to here, and from here all the way around. Tell me those degree measurements just to make sure you understand that, right? And when we're doing this right here, the direction we're going in is called clockwise. But that isn't the only thing we're going to be using. We're going to be using counterclockwise direction as well. Counterclockwise. So instead of going to the right, we're going to be going to the left, the opposite of a clock, right? So from here to here will be 90. From here to here will be 180. From here to here will be 270, and so on. Okay. So go ahead and pause this after I'm done talking and draw the axes and practice this clockwise and counterclockwise. Then come back and check your work. Go ahead and pause. All right, next slide. This question says, rotate around the origin 45 degrees clockwise. Okay, clockwise means going to the right. Perfect. All right, so I have this heart right here. All right, I know that from here to here is 90 degrees, so halfway represents 45 degrees. So the middle of this heart should be right here on 45. So I know my heart should be looking something like this, right? Really, it should look like the same exact heart because they're congruent figures. But we are not really artists, right? Most of us probably aren't. So I'm not going to expect it to be perfect, right? But it should look like a heart, and it should look like it's similar in size, even though they should be exactly the same, right? So say if this was the original image and then you rotated it and then put a little heart, no, you cannot do that, right? They should look pretty much the same size. So this is 45 degrees around the origin, right here. Next slide. Rotate around the origin 180 degrees clockwise. So I'm going to use this as my reference point of 0. I need to do 180. Well, I know from here to here is 90. From here to here will be 180. All right. But, how is this going to go? I know it's going to be somewhere right here, but I'm not going to put it like this because if I do this, that's a translation. I'm bringing it directly down. That's not what I'm doing. I am rotating it. So what that means is, see this little pointy part at 4? This distance is 4 away from the origin. Here's 0, right here. It's 4 away. This pointy part is 4 away. So the bottom part of this heart should be 4 away when I rotate it. So this will be where the pointy part is. So it should look something like that. Okay, and again, they should be the same exact size, but I know that we cannot make it the same exact size, so just try your best to make it look the same size. All right, so that represents 180 degrees clockwise. And that could also be 180 degrees counterclockwise. It's still the same thing. Okay, and if there is a distance away from the point that you're rotating, it says around the origin, keep that same distance away the whole time. If you look back at the other slide, there was no distance It was exactly at the origin, so then we just kept it at the origin with the new image, as it should be. All right, next slide. So in the previous example, you could say that that is that looks like a reflection, because it does look like a reflection, but it's a rotation. All right, for what we're doing, because it said to rotate, so it is a rotation. All right, this one says rotate around the origin 270 degrees clockwise. Okay, let me put my reference point here at 0. But that will kind of make it harder to rotate it. So wherever I put my 0, I want to put above where my image is. What? I'm going to create a whole new X and Y axis to help me. If this is 0, from here all the way to here would be 90 degrees. From here all the way here will be 180 degrees. From here to here will be an extra 90, so that would be 270 degrees. So if your image is not on an axis, or this axis, that can't be 0. You have to start it above where that image is. Well, you don't have to, but it makes it a whole lot easier. Right, so I suggest putting your 0 there. So move those axes to help you, right? And then ignore these lines, right? You can ignore them or use them as your halfway points. Up to you. So I'm going to erase those squiggly lines so that they don't get in my way of my work. And I'm going to use a different color. It says rotate around origin 270 degrees clockwise. Okay, around the origin. So I know that there's a space between here and here. I don't know the exact space. There isn't a number that's given to me. Like in the last one, there was a number that was given to me. It was like 4. This time it's not given to me, so I'm just going to approximate. And that is okay. Right? So rotate around origin 270 degrees clockwise. So here's 270 degrees. I'm going to try matching that same distance away. Let's maybe around there. And then put a triangle. And remember, it should be the same exact shape. All right, 270. From here at 0, this is 270 degrees clockwise. Makes sense because it's 3/4. All right, next slide.
Okay, it's me, Addie. So I figured a good mind break video would be showing you how I feed my pigs. So here is the food right here. I have it all stacked up already. I have 3 pigs, and all the bites are from our dogs when we accidentally leave the cups outside. So let's go outside. All right, these are some of our dogs. That's 3 of them. That's Sassy. That one's Sassy. That's Mocha, the poodle. And that's Jasper over there. Okay, let's go walk over to the pigs. Well, this one is Freckles. So Freckles knows it's dinner time. So let's go in there. Say hi, Freckles. And then give her her food. Okay, there she is right there. Alright, she looks kind of dirty, but it's from all of her hay that she likes to play and sleep in. So that's her right there. Alright, let's go to the other animals. Okay, lock that. Alright, here is Snowball, our rabbit. Very soft. This is Mocha. Mocha, he already saw you. And here's Wappa. Say hi, Wappa. Look at Wappa. How cute Wappa is. And Cookie's in there somewhere. She's in there. She's in the little house. So maybe I'll come back. Alright, now we're going to go to the other pigs. That's Lily. cattle dog. All right, all right. We put that one down. So that's Daisy Mae, the mom. That's Twinkle Toes. And over here, they put their little bowls over here. And we just dump the food in there. See, Daisy Mae's going to hers. Okay, there we go. And they revolve around the food. And this is their area. Okay, and their little hideaway. They like to climb up there, say hi to the neighbors. So there's Daisy Mae. Daisy Mae! Daisy Mae! She's hungry. Twinkle Toes. Okay. The dogs. Our dog walks. Lily wants to play with her frisbee. There she goes. Alright. Then we have tortoises over there. Oh, here's our garden we just made. And here is our pond. Alright. It's coming back to life. It died in the winter, but it's definitely coming back to life. You can see some of the fishes. We have goldfishes in here, and I'm not sure if you can see all the little mosquito fish swimming around. They're good for mosquitoes. Some more fishes, a waterfall. I need to clean the filter. But yeah, so this is our pond. Great pond. And yeah, that's our yard. Our pets. Our cat is inside, and our gecko's inside as well. Alright, hope you enjoyed it. Say bye, Mocha. Say bye, Mocha. Say bye, Mocha. Say bye.
Alright, rotate around the origin 270 degrees counterclockwise. So after I'm done talking, go ahead and pause this slide and go ahead and try this one on your own on your paper. Go ahead. Alright, so you might want to make that 0 here. Draw your new axes. Alright, so it says counterclockwise. So instead of saying this is 90, this is 90 degrees this way, this is 180 degrees, and this is 270 degrees. So rotate counterclockwise. So here would be 90, here would be 180, and this is the image that I want right here. Okay. There we go. Perfect. If you are drawing multiple hearts like I did right here, you could circle the one to show me that that one's your final answer, or you can put a star on it, whatever works. Okay. All right, next slide. All right, go ahead and try this one. See what you do, what you can do. Go ahead and pause it and try it. So this one says rotate around the origin 45 degrees counterclockwise. Okay. So, all right, so my image is here, so I'm going to start off 0 there. And then draw my new X and Y axes. All right, so I know, and it says counterclockwise, so I have to go to the left. This is 90, but it says 45, so I have to go halfway. Here represents my halfway point, so this is 45 degrees. Remember earlier I said you can erase those or keep them because they can mark your halfway point. This is an example of it marking your halfway point. So that means that the top of this triangle must be right here. So then the triangle will look something like this at 45 degrees. All right. Next slide. All right, this one says rotate around the point 90 degrees counterclockwise. Go ahead and try this one. Pause it. This one was a little tricky because it's not having you rotate around the origin. It says rotate around this point. So a good thing to do is draw your own axes around it. Well, this should go through that point. Okay. All right, so counterclockwise 90 degrees will be going this way. There's about that much distance, so keep it the same distance. And it should be the same looking heart, but that looks pretty bad. So let me do that. Let me do that whole point, that whole part again. Make it a little more clear. All right, so here it looks like that much distance, so right there. And then I'm gonna put my heart. Kind of hard. It's kind of difficult to draw a heart sideways. All right, so there you go. That is 90 degrees counterclockwise around this point. So before I mentioned that you can rotate it around the origin or a specific point, this is an example around a specific point. Next slide. All right, go ahead and try this one on your own. Go ahead and pause it and then come back. All right, so let me draw our new axes, 180 degrees clockwise from here to here. So I can put my 0 degrees here, and then this is 180. So keep it the same distance away. It should look something like that and shade it in because the original one is shaded in. It really should be blue because it's the same image, but you're working with pencils, so just shade it in. All right, next slide. All right, now this is one of my favorite transformation problems. All right, it says, where would it be? Where would this triangle be if you rotate this triangle 90 degrees clockwise 11 times around the origin? And then it says, what if you rotate it 90 degrees counterclockwise 11 times around the point 0.06? Okay, so go ahead and try the first one and see if you can understand what I'm talking about. Pause it and try it and then come back. All right, let's look at the first one. So it says, where would this triangle be if you rotate this triangle 90 degrees clockwise 11 times around the origin? So it says clockwise, so I'm going to go to the right, 90 degrees 11 times. So from here to here, that's 90, and 90 again will be here. So this is 1 rotation, 2 rotations, 3 rotations. So 1, 2, 3. Gotta do this 11 times. 3, 4, 5, 6, 7, 8, 9, 10, 11. This is the position it would be in 11 times. Okay, so this doesn't represent 159. They were just my little marks to show you how many times we were rotating. All right, where it would land on which number of rotations. All right, so for question number 1, this image was over here. This was the answer. So I just erased it so that we can have a cleaner space. So this is answering this question around the origin, keeping in mind that there was a distance in between. Okay. Because if it's about the origin, then there is that distance. Here's the origin. There's that distance. You got to keep it all the way around. But B is slightly different. Not just because it's asking you to go the other way, counterclockwise, but because it says around the point 0.06. So let me erase this. We are going to rotate around this point right there. Let me make it a different color. This point right there. All right, 90 degrees counterclockwise 11 times. So one way will be here, second way would be here, and the other way will be there. All right, so from here to here is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. This would be the triangle. When rotated 11 times, 90 degrees, counterclockwise. Okay. So keep in mind, make sure you're reading. When it says around the origin, you're going around the whole image around this point right here. But if it's saying around a specific point, here the origin is a specific point. It's right there, 0, 0. But if it's saying another point, then you got to keep that in mind and make sure you're doing it around 0, 6. That is the coordinate right there, 0, 6. Next slide. So let's review these rotations again one more time. It says, where would this triangle be if you rotate this triangle 90 degrees clockwise 17 times around the origin and then around 0, 6. So go ahead and pause this after I'm done talking and practice this again. Even though I had you review the last one, these ones are really good questions and I want you to be comfortable with them. So go ahead and try them and then come back. All right, it says, where would this triangle be if you rotate this triangle 90 degrees clockwise 17 times around the origin? So here's the origin here. Remember, I got to keep that distance, but 90 degrees clockwise 17 times. So let me just draw them all out. They don't have to be perfect for now. So I'm going to go 17 times to the right because it's clockwise. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17. Let's do that again just to make sure. So the original one doesn't count because it's in the same position. So 1 90-degree rotation. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17. So this right here is the answer for part A. Okay. Now part B says, what if you rotated 90 degrees counterclockwise 11 times around point 06? So I'm going to keep the answer for part A right there. Oops, never mind, I accidentally erased it. That's okay. And then I'm going to look at this triangle right here. And I need to rotate it around this point. So I'm going, it's 90 degrees, so I know there's going to be 4 of them. So 1, 2, oops, 3, and 4. Okay, so let's see, rotate 90 degrees counterclockwise. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Oh, it lands kind of in the same direction as part A. So this is where this triangle would be. But I'm going to erase it and rewrite it because if you look, I don't even have to fill it in because the original one wasn't filled in. So that one is my image right there. Okay. All right, next slide.